Today we'll be talking about Arbitrum Stylus, which is a new project that what we call EVM+. We are supercharging EVM development by allowing developers to write equivalent smart contracts in Rust, C, C++, and a lot of other languages that support WebAssembly. You can even add support for your own language. And we'll walk you as well on a workshop on how to actually get started and how to get your first Stylus contract deployed, and just basically see how easy it is to get something that is just EVM, interoperable and just works out of the box. So without further ado, we know that rollups are awesome, and they settle basically their state to Ethereum. Users interact with them. Transactions get packaged up and rolled up into a batch and get posted back to L1. And rollups have different implementations of how they actually choose to package this information and what they actually prove over regarding their state transition function. Arbitrum today works by essentially taking the Ethereum state transition function, adding a few modifications, and converting that into WebAssembly bytecode, which then gets proven on Ethereum. So at the end of the day, what we do is that we actually prove that every transaction as it was executed on Arbitrum gets confirmed on Ethereum and if there's a fault in a single opcode execution, we can prove that there was a flaw right there. And why did we choose WebAssembly for this? So WebAssembly was a choice for Arbitrum because it's a very simple binary format that has an extensive community behind it. So many languages also compile to WASM, and it's a big part of the web standards committees. We also argue that it's excellent for fraud proving on L2s based on the way it works. Being a stack-based machine, providing opcodes that can be constrained in certain ways, gives us really nice properties that have powered Arbitrum for quite a long time. And of course, JavaScript has always been the de facto language of the web, with many other flavors coming in over the years. But most importantly, that narrative has begun to shift to a certain extent with WebAssembly being introduced. Today in production, you can run applications that are written in Rust, C, and C++ and run them in perhaps the most adversarial environment that exists out there today, which is web browsers. Web browsers today are battle testing production applications that are running WebAssembly code and with significant results and speed to boot. We see applications such as Figma. We see applications that rely on heavy rendering and processing that are actually using Rust underneath the hood and running in the browser as WebAssembly. So we asked ourselves the question, hey, can we do more than just execute EVM smart contracts on Arbitrum? Well, it turns out that with L2s, you can prove general computation. That is, of course, deterministic, I should add. And as Arbitrum state gets settled to Ethereum using fraud proofs, and we're already using WebAssembly, why not just extend that to support user-provided WebAssembly as well? And a quote that we like to mention about how impactful WebAssembly is Solomon Hykes, actually, the creator of Docker, said in 2008 that if WASM as a technology, along with WASI, which is a standard library for WASM, had existed back in 2008, they wouldn't have needed to create Docker. That's how important it is, and that's how important WASM on the server is for the future of computing. All right. So introducing Arbitrum Stylus. Stylus is a next-gen programming environment for Arbitrum chains. You can write smart contracts in many different languages, but that's not only the main selling point. The main selling point is that we don't have to make a compromise or a choice as a developer between EVM or WASM. Instead, one chain, multiple languages, one chain, multiple VMs. It's fully composable, it's not a new L2, and we're calling this EVM+. We have one single state transition. We use the same state tree as Ethereum in the same database. And we combine two VMs, being the EVM and interpreted EVM, and WebAssembly runtime using a WASM or server backend. And we combine the two. There's nothing else like it. Some of the numbers. So Stylus is significantly faster. It's not just like, hey, you can use a different language in Solidity. But actually, we can benchmark 73x compute performance against Kachak. This translates directly into saving and slashing user fees. It also enables things that just weren't previously possible, such as advanced cryptography that would otherwise overflow the gas limit on EVM chains, gaming, AI, and L1 precompile research. Instead of waiting for many years for Ethereum to ship a new precompile, you can program it in Rust and ship it on Arbitrum. Not only that, but we can estimate the amount of developers that exist in other languages that can now come into developing on an EVM chain thanks to the availability. What's really special about Stylus is that for the most part, you can write pure Rust. So we're not introducing our own required DSL where we say like, hey, no, it's like a weird flavor of Rust that has to work in a certain way. No, we provide an SDK, but anyone can build their own. If you want to interact with the EVM or do things that are EVM related, you can say, give me the block number, give me the block timestamp. You have this low-level kind of syscall-like API to get things done. You can call contracts, you can interact with storage. And just as the JavaScript world developed a huge flavor of frameworks, you can build your own. If you don't like the Stylus SDK that we provide, nothing is stopping you. It's not enshrined into the protocol. At the very lowest level, Stylus contracts actually are just bytes in and bytes out. So if you want to write basically a pure computation on the blockchain that just takes in a bytes input and outputs a bytes output, you can do that. And it's as simple as doing this. You want to add support for new programming languages. So Zig is all the rage these days, being a spiritual successor to C. Almost any language that doesn't have a runtime can be used with Stylus. Adding support for Zig, for example, took me around 16 lines of code, and I'm running Zig smart contracts today on Stylus. As a team, we provide first-class support for Rust and C, and we have SDKs that are available to use for hackers here. And we'll do also a walkthrough on how to program some of these. Testnet is live. So the testnet is basically is a chain that branches off Arbitrum Sepolia. And you can bridge into it. We have a quick start guide that guides you through the process. It's as simple as getting testnet ether, bridging it over, takes a few minutes, and after that, you can go free to go wild. With just a simple amount of testnet ETH, you can do an insane amount of things, compute deployments on Stylus, just because it is that cheap compared to running EVM-related code, even on the testnet, of course. Question is when? Testnet is out, mainnet sooner than you think. For it to be deployed on Arbitrum 1 in Nova, it would have to go through the DAO for approval, and we are currently working on both an audit and basically getting to that point. We have all the EVM contract interoperability. So you can have a Solidity smart contract that's talking to a Rust smart contract via an ABI interface, and they don't even need to know anything about each other, right? That's all abstracted underneath the hood. And you have endless possibilities, right? SIP hash and C, for example, here is implemented, deployed on Stylus, extremely cheap to execute. To give some numbers, in the time the EVM can do 7 add instructions, we can do a full round of SIP hash, and we can do it a lot cheaper. Memory-wise, for memory operations, Stylus can be 100 to 500x cheaper on memory than EVM-related operations, simply because the memory model is that inefficient in the EVM. And yes, so you can contact us here. But before we wrap this up, I'm going to walk you all through a live demo of how to get started. Okay. All right. So the first thing is we provide a tool called Cargo Stylus, which if folks here have used Rust, Cargo is your go-to command for doing everything in the Rust ecosystem. And having this plugin for Cargo is very simple. It comes with 4 commands. You can initialize a new project. You can check that it compiles and will deploy on-chain. You can actually deploy it on-chain. And the coolest part, you can export ABI. So you can write your contract in Rust and export a Solidity ABI that then your other contracts in Solidity can call into and do a lot of cool things. And we'll talk about how you can do that. So Cargo Stylus, that's the first thing you're going to install. You're going to do cargo install Cargo Stylus. And I'll save you all the long Rust compile times, of course, here. But once you get that installed, you'll have access to all the tools you need. So you have all the different ABIs, all the different commands here, and there are a few others that weren't included above. So you can even replay transactions in a debugger, which is really cool. You can use traditional debugging tools with Stylus contracts because you're not limited by the EVM. You can trace transactions and trace exactly kind of certain things that occurred in the execution, giving you a lot of interesting powers as a developer. The next thing that you want to be aware of is the Stylus Hello World repo. So the Hello World repo is our minimal, it's not the most minimal entry point, but it gives you a Solidity equivalent counter implementation. So basically you have a counter contract, you can increment, you can set the number and fetch the number, and we're going to be implementing this today. Cool, so let's get started. So I cloned the Stylus Hello World repo here on the left. Comes to you with a few different things. It comes to you with the main.rs, it comes to you with the lib.rs, and interesting things you can do. And we're going to actually implement it from scratch. So inside of this, this example.rs, what I'm going to do is I'm going to be importing the Stylus SDK. I'm going to import the prelude, which includes pretty much everything you're going to need here. And I'm also going to include the, let's see, I'm going to include some primitive types such as uints, or just all the alloy primitives. So we use the alloy library, which is being created by the ethers.rs team. And the alloy library has extremely optimized data structures and primitives for use in Ethereum applications. It's really cool because they have awesome features such as constant generics. They're super fast, and they work out with Stylus right out of the box. For folks that are wondering if you need to develop smart contracts with the standard library or not, both work. You can use the Rust standard library, or you can choose to deploy contracts without the standard library, and both will function with Stylus. So the first thing we can do is I could program this basically in pure Rust by declaring structs and declaring all these things. But for Solidity developers, the SDK provides an easy way to kind of accommodate and get more used to the Rust syntax. So we provide a really a macro called Sol Storage. In this storage, you can define Solidity structs. So you can type Solidity syntax in here. So in this case, I'm going to be doing a struct called counter. And I'm going to be adding a value called number, which is a uint256. I'm going to also be marking this as an entry point for my application. Cool. So this entry point means that, hey, this struct is basically the entry point for transactions that are coming in to this program. And I need to then implement a few methods for this to occur. So I'm going to be implementing the counter struct. And I'm going to mark it as being basically the implementation of the Solidity storage struct. Next, I want a few methods on this. So as a hello world example, we need to be able to modify the number value that is contained inside the struct. Underneath the hood, this is all using the Ethereum storage model, the Solidity storage model specifically, and using the Ethereum state tree. So you have access to all those goodies that you're familiar with. So we're going to be implementing a method here on this counter struct. It's going to be called setNumber. And it's going to take a mutable reference to self, so we're able to leverage also Rust's memory safety here and common patterns in developing applications. I'm going to take in a number. It's going to be a uint256 from the alloy library. And it's going to return a result. Cool. So it's going to return a result where the first return type, the success case, can be anything. In this case, it's going to be void. It's going to be the unit type. So I'm not going to return anything if I set a transaction. And it can return an error, which is raw bytes. So if you want to return a custom error, you can return it as raw bytes, and the caller can then interpret it as they want. Cool. So in this case, I have an n, and I want to be able to update the number value here. So I'm going to do self.number, and numbers in the SDK. Values that are SDK values, you have access to a lot of very powerful methods on them. You can do load, which loads it from storage. So essentially it does an store. The cool thing is that Stylus is optimized to not do an store every single time you load. Instead, we use a caching model where if you load something once, it'll be cached until you then flush to storage. So you get a lot more control over storage access patterns in your contracts compared to doing something in Solidity without some underlying changes that you would need to do. In this case, the number has a set method that I can then modify. And this will actually modify it in Solidity storage inside of Arbitrum. The set method will return, I believe, a result. Or let's see here. No, it just sets it, and that's it. So that's basically it for our mutating function. We also want a getter for our number. So we're going to be returning a result type that's U256. And it's also, the error case is just a bunch of bytes. And in this case, I'm going to do self.number.get. Cool. I probably also want one more method, which is increment. So basically, take the current number that's in storage, add 1 to it, and just return. So it's going to take a mutable reference to self. It's going to take no arguments, and it's also not going to return anything. It's just going to increment the number. So what I'm going to do here is I will do let mute num equals self.number.get. And I'm going to do self.number.set num plus u256 from 1. And this should return a result by itself, I believe. Let's see. Actually, no, it does not. So I think we're safe. Okay, cool. So we have our getter, we have our setter, we have our increment function. Let's see what we can do with this. So the Stylus Hello World repo already comes with this example pre-filled out. So I was just writing it here from scratch. But in the actual library, you'll have this already implemented for you. So you have access to it right away. So you have the increment, the set method, and also the entry point. Let's see. Computer is pretty slow for some reason. Let's see. Does anyone have an adapter for USB European? I have a charger right here. Let's see. Oh, thanks so much. Thank you so much. Yeah. All right, thank you guys for bearing with us here. Perfect. All set, thank you. Okay, so back to it. So here we have a few cool. We have some comments here added on. You can also declare a custom global allocator for your application, so you don't need to use the normal allocator. There are some allocators in Rust that are optimized for WebAssembly, so we do this here by default, but you can choose to do things however you wish. So now that we have our contract implemented, what do we actually do with it? How do we actually get it on chain? How do we actually do interesting things with it? So with the Cargo Stylus tool, you can check that it's going to verify on chain. Oh, it seems here I duplicated I implemented the example twice. So cool. So you can see here that if I do Cargo Stylus check, what it's going to do is it's going to try to compile my code to WASM. It's going to tell me how big it's going to be on chain. And it's going to try to deploy it to the testnet without actually sending a mutating call. So it's going to check that it's going to succeed the checks. If that works, then you're good to go. So it looks like my application succeeded the checks. What I'm going to do next is I'm going to do Cargo Stylus deploy. Oh, okay, Cargo Stylus deploy. Awesome. So I'm going to pass in my private key path to the testnet, and I'm going to be deploying it. So Stylus programs have 2 steps for deployment. So the first one is just getting the code on chain. So getting the code on chain is the first step. The next step is actually doing an on-chain activation. So you have to basically activate the WASM code to be usable on chain. This is an optimization that we do. So if somebody already activated the same code as you, the Stylus, the protocol will use that already activated WASM code on chain, and it'll just work. So it's a way for us of deduplicating execution. And I basically deploy my contract. It's live. That's awesome. It's deployed to this address. Okay, let's save it here. And we're going to be exporting this address as an mvar right here. I'm going to use it a little bit later. So now that our contract is on chain, it's on the testnet. I want to be able to interact with it. I want to call it. I want to talk to it, right? So using the Cargo Stylus tool, once again, you can do Cargo Stylus export ABI. See what happens there. There we go. So your Rust smart contract, here's a Solidity interface for it. And this means that from any other Solidity contract, you can make a call to it. You can transact with it using your favorite tools. So we have the ABI, which is really cool. Let's actually try to interact with it. So let's make a transaction. How can we do that? Well, you can use any kind of Ethereum tooling that you're familiar with. In this example, we love maintaining our same development stack as Rust. So we have an example here in Rust that shows you how to call your contract using the Ethers library, which is a very popular library for Ethereum development in Rust. Here I declared the ABI for my contract. And basically I have methods to be able to then interact with it using Ethers ABI gen. So it's really cool. Let's see here. Looks like I'm lagging a little bit. But you can run this example. You can do cargo run example. And actually, let me see. Yeah, we're going to do cargo run example counter. What it's going to do is it's actually going to use the Ethers library in Rust to interact with my contract. So the Ethers library made an ETH call, and the counter value is 0, and I'm going to try to increment it. So it's sending a transaction. It incremented. The new counter value is 1. If I interact with it again on the testnet, the value is 1. I'm incrementing it again. The value is going to become 2. Cool. So we have a new counter value of 2. So this is just using standard Ethereum Rust tooling to interact with your program that you wrote in Rust via Solidity interface, which is really powerful. So aside from this toy example, what other cool things can you do? So we have the Stylus SDK, which is written in Rust. And recall that this is just a nice thing that we provide, but you don't need to use it. You can write your own framework on top of this because, once again, the API to the EVM is so low level that you can choose to implement it any way that suits your needs. The SDK is meant to provide an experience that is easier for Solidity developers to become more familiar with it and has access to already all kinds of things for you, including storage layouts, and includes an example ERC20 token in Rust that exports the correct Solidity interface for it. You can declare events as well using our macros. You can declare errors as well in Rust as enums and get all the power that Rust enums have to offer and essentially just go wild. You can also execute this, and we have examples on how to interact with it. Okay. Aside from that, there's an awesome Stylus repo on GitHub where you can see some of the projects that have already been built along with some guides and useful information. So Uniswap v2, for example, with the same ABI interface written in Rust. We have cryptography examples. So most recently, P256 verification written in C. We have BLS signature verification written in C as well, and extremely fast and executing cheaply on Stylus. So you can do all kinds of crazy things. You can verify a BLS signature. And also NFTs. Projects that we are interested to see are more Ethereum standards ported over into Stylus, and seeing things such as proxy patterns, seeing just other examples of crazy ideas that folks might have. You can even take existing Rust crates and just deploy them almost right away in vanilla and turn them into smart contracts. Just add an entry point, add a way to get data or set data, and there you go. And let's see. So yeah, docs are available, of course, on the typical Rust tooling, so docs.rs for the Stylus SDK. You'll find information on all our different modules, including EVM affordances, message sender, storage, TX origin, like everything you might want, cross-contract calls, you can do anything. And you can navigate to arbitrum.io/stylus to just learn more and have access to all this information. We are offering a $4,000 bounty specifically for Stylus at the hackathon, and we'll be active on our Discord, so please join into the Arbitrum Discord if you have any Stylus questions. And let's see. And once again, my information is here. So the lead developer is Rachel, who is not with us today, but I'm Raul Jordan. You can find me on Telegram as Cypherpunk or rjordan at offchainlabs.com. And yeah, we're just really excited to see what folks might build. So thank you. All right, question? Yeah?
You had a graph with Rust and C next to it. What is that?
Oh, yes, sure. So Rachel has the sources on this information, but I believe we did some gathering of the estimated number of Solidity developers versus Rust devs versus C++ devs. Yeah, I should have prefaced that. But yeah, we estimate around 20K Solidity devs, 3 million Rust devs, 12 million C++ devs. Yeah.
Maybe I missed it. How does the gas pricing and stuff work?
Yeah, great question. So, of course, WASM smart contracts, have different gas pricing than the EVM model. At the end of the day, when you're interacting with a Rust smart contract using traditional tooling, you'll be paying gas, the same as Ethereum gas, right? But underneath the hood, the pricing, there's a translation between EVM gas and Stylus gas. We call Stylus gas ink, actually. So there's a ratio of gas to ink that we price accordingly based on how we think, how much cheaper is a WASM edition versus an interpreted EVM edition. And we price things accordingly like that. So yeah.
So basically you have a different VM.
Yes, we're using the WASM or VM. Contracts are still stored in the state tree for Ethereum. They interact via the same, they run in the state transition function. And they were also fraud proven, like Ethereum transactions. Yep.
So in the example you used Rust example to prepare a Solidity interface.
Yes.
And maybe can you provide one or two examples how we can use this interface?
Sure. Sure. So the example that I gave here in the Stylus Hello World repo, here is I'm using the Ethers library in Rust. And the Ethers library in Rust allows you to basically, you can paste in an interface, like a Solidity interface for something, and use the Ethers library to interact with it. So here I pasted in the interface from the contract that we just wrote, which here's a Solidity interface. And I can call it. I get Rust bindings to it. I can do number, set number, increment. You can call it from other Solidity smart contracts. You can call it using cast or using a MetaMask transaction. Just like you would talk to any Ethereum smart contract. You can talk to your Rust smart contract. Yeah. All right. Any other questions?
So you can
Sure.
use third-party Rust modules.
You can use Rust crates and go wild, try it out. Those that support the standard library, those that don't. Right now we don't support floating point, but that will be coming in the next few months. It's a little bit difficult, but we're working on it. So anything that's deterministic is fair game. Yeah. Okay. Thank you all.